Okay, so today we're going to talk about special right triangles. So on Tuesday, we talked about all right triangles. So all right triangles work for the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared. So if you know two of those, if you know a and b, or a and c, or b and c, if you know two of the three sides, you can find them. So the limiting factor in the Pythagorean theorem is you have to know two of the sides. If you only know one side, the Pythagorean theorem isn't going to help you out all that much. Okay? What we're going to talk about today are special right triangles. So not just any right triangles in the world, but two specific types of right triangles that you don't have to even know two sides. That if you do just know one of the sides of the right triangle and it fits one of these cases, you can find the other two sides. So these two right triangles are going to be the 45, 45, 90 triangle and the 30, 60, 90 triangle. So the numbers are referring to the angle measures. So both of them, obviously they're right triangles, both of them have a 90-degree angle. The first one is the 45, 45, 90 triangle theorem. So it means you have your 90-degree angle, and the other two angles are both 45 degrees. So they are congruent, which means, what kind of triangle would this be other than a right triangle? It would be an isosceles triangle, and you can kind of see that a little bit off of the picture. But if you have these two angles are congruent, we had a theorem from a few chapters ago that says if you have an isosceles triangle, the sides opposite the congruent angles are also going to be congruent. So you can see here that if this bottom leg is S, then the leg that goes up is also S. They are congruent. Whatever one leg is, the other one is as well. Because it's an isosceles triangle, they're going to be congruent. So the hypotenuse in a 45, 45, 90 triangle is always going to have the same relationship with both of the legs. Regardless if the legs are 2, or if the legs are 20, or if the legs are 100. The hypotenuse is always going to be the length of the leg, so 2 or 20 or 100, times the square root of 2. And that comes from this one's a little easier to figure out than the other one. If you were to do the Pythagorean theorem, you'd have s squared plus s squared, 2s squared, equals the third side, okay? And then if you were to solve that in terms of s, that's how you would get the s square root of 2, okay? So what you're going to do here, and this one's pretty simple, I would say, for the most part. So let's say in this triangle here, we have this leg right here is 9, which we know since it is an isosceles triangle, and since both of these angles are 45, that leg is also going to be 9. If I wanted to find the length of the hypotenuse in a 45, 45, 90 triangle, the length of the hypotenuse is going to be the length of the leg, so 9, times the square root of 2. Just a little bit bigger. So legs are 9, the hypotenuse is going to be 9 square roots of 2. A little bit bigger than that. So some of the problems today are really easy, because that's all you have to do. Okay? Some of them take a little bit more work, but I would say probably the more difficult thing about what we do today is probably the radical operations and not necessarily the geometry part of it. So the trickier of the two special cases is probably going to be the 30, 60, 90 triangle, just because you don't have two congruent sides. You're going to have a scaling triangle. You're going to have a triangle that doesn't have any congruent sides, but there is still a relationship between the side lengths. So in a 30, 60, 90 triangle, the side that you want to base everything else off of, so in the 45, 45, 90 triangle, it was the legs, right? You start with the legs. If the legs are 5, the hypotenuse is 5 square roots of 2. If the legs are 10, the hypotenuse is 10 square roots of 2. So you need to find the legs first, and then you can go on from there. So in the 30, 60, 90 triangle, the side that's going to be that one for this is going to be the shorter leg. Okay, it's going to be the shortest side. That's what we're going to call, let's say, S. So if we're going to use our formulas, we're going to call it S. How you're going to know, not just by looking at it and saying, oh, it looks like the shortest side, but actually knowing it's the shortest side, it's going to be the side across from the 30-degree angle. Because we also had a theorem that said the side across from the smallest angle is going to be your shortest side. So you're going to find your 30-degree angle, the side across from that, that's going to be your S. That's what you're going to start with. Now, the hypotenuse, this is an easy relationship, easier than the other one. Once you know the length of the shorter leg, the hypotenuse in a 30, 60, 90 triangle is always going to be twice that. So if the shortest leg is 5 in a 30, 60, 90 triangle, the hypotenuse is going to be 10. It's double it every single time. Okay? Now, for the other leg, so the longer leg, it's going to be kind of like the hypotenuse in the 45, 45, 90 triangle. It's going to be S square roots of 3. So, if the shorter size was 5, the hypotenuse would be 10. This other leg is going to be 5 square roots of 3, just a little bit bigger. Okay? Now, if you're given the shorter side of the hypotenuse, these ones are pretty straightforward, they're pretty easy to work with. But what happens, sometimes you're not given either one of those, you're given a different one. So, like in this one, okay, I wanted to find the length of D and F. Okay, now remember, for the 30, 60, 90 triangle, you really want to figure out what the length of that shorter side is, the shortest leg. If you can find the length of the shortest leg, which in this case is side opposite 30, it's going to be this one here. The rest of the sides are pretty easy to figure out. Now, in this case, they don't give me that. Now, if they give you the hypotenuse is pretty easy to figure out the rest of them as well. Like if hypotenuse is 20, that would be 10. Right? Because the hypotenuse is double that shorter leg. But in this case, I don't have the hypotenuse either. What they give me is they give me the other leg. They give me the 5. Okay? Now, here's how you're going to do this. Where that 5 came from. Okay, the formula to find the length of that leg is S square roots of 3. I don't know what S is. Square root of 3 is kind of funny. But I took S, whatever S is, and I multiplied it by the square root of 3. When I did that, I got 5. I don't know what S is. I don't know what S square root of 3 is. But I know when I did that, I get 5. So you're going to have to set up an equation. And you're going to have to solve for S, which is going to be the length of that shorter side. Now, to solve for S, how would you get rid of that square root of 3? Divide by the square root of 3. Okay, so we have S equals 5 over the square root of 3. Now, since it's my first year teaching geometry and I am learning along with you guys, I realized that I probably should have gone over like all of the simplifying the radicals, not just like the cake and the dividing out common factors one, because this is not in simplest form. Do you remember why? You cannot have a radical in the denominator. Remember that from last year. Now, a lot of these, this is called rationalizing the denominator. A lot of these in this section are easy to fix. They're not like the super difficult ones that you would have done last year. You cannot have a radical in the denominator. It's not considered simplest form. So to get the radical out of the denominator, you're going to multiply the numerator and the denominator by the radical you're trying to get rid of. So I'm going to multiply by the square root of 3 over the square root of 3. Okay? Because the square root of 3 over the square root of 3 is 1. Right? Because 3 over 3 is 1, 10 over 10 is 1. 100 over 100 is 1. The square root of 3 is square root of 1. I'm multiplying by 1, and you can multiply by 1. That doesn't change anything. Now let's talk about how to multiply radicals, because me not being, a seasoned geometry teacher, I didn't realize we needed to review this. When multiplying radicals, if you have numbers that are both under the radical sign, you can multiply them together and keep them under the radical. If you have numbers that are outside the radical, you can multiply them together and keep them outside the radical. But what you cannot do, you cannot multiply a number outside the radical with a number inside the radical. So like here where I'm taking 5 times the square root of 3, you can't actually take 5 times 3. What you would do here is you have to leave the 5 outside and you have to leave the 3 inside. It'd just be 5 square root of 3. Okay? Now, in the denominator, I'm taking the square root of 3 times the square root of 3. Those 3's are both under the radical. I can multiply those together. Okay? So you would take 3 times 3, which is 9, but they have to stay under the radical. Well, what is square root of 9? So you would get 5 square roots of 3 over 3. Now, just like I said, you can multiply things on the outside with things on the outside. You can multiply things with the inside, but you can't mix and match. It's the same thing when simplifying and dividing. So although you might be tempted to divide up these 3's, that 3 is inside, that 3 is outside, you can't simplify those. So this is what S is. This is the shorter side of your triangle. That's what D is. Now the other thing I need to find is I need to find F. Okay? To find F in a 30, 60, 90 triangle, once you find the shorter leg, the hypotenuse is always going to be twice that. So to find F, to find the hypotenuse, you are going to take 2 times 5 square roots of 3 over 3. Remember those rules. You can multiply numbers on the outside with numbers on the outside. You can multiply numbers with the inside with the numbers on the inside, but you can't mix and match them. So the 2 and the 5 are both outside the radical, so you can multiply those together. You cannot multiply them by that 3, and then that other 3 is in the denominator, so you would get 10 square roots of 3 over 3. Like I said, I think today, probably the toughest part about today is the radical part, not necessarily the geometry part, okay? All right, let's get this glued into page 21. This is section 8.2, special right triangle. Okay, so for these first 4 examples are going to be similar to what you're going to be doing in your homework today. They're going to be a little more straightforward and simpler than the last 2. Number 5 and 6, you're not going to have problems like this in your homework for today, but on Monday on your worksheet you will. So I thought we'd just get them all out of the way, get a little extra practice today, and then Monday will be whenever you look at those for your homework problems. So number 1, we're going to draw a 45, 45, 90 triangle. And we're going to have that bottom leg be 2 square roots of 2. The hypotenuse is going to be x. Now, they only give me one of the sides, but we kind of talked about, we know that this is an isosceles triangle. So what does this other leg measure? It's the same, right? It's also 2 square roots of 2. Okay, so the relationship between the legs and the hypotenuse in a 45, 45, 90 triangle, you're going to take the length of the legs, whatever it is. I know in the other ones it was pretty simple. It's like 5, 6, whatever it was, 7, I don't know what it was. And you just multiply by the square root of 2. Whatever the length of the leg is, you multiply by the square root of 2. So to find x, we are going to take the length of the leg, 2 square roots of 2, and we're going to multiply it by the square root of 2. And then, of course, simplify this out. Remember, you can multiply the things on the outside with things on the outside. You can multiply things with the inside and with the inside, but you cannot mix and match them. So I can't multiply those 2's, but I can multiply these 2's. So when you take 2 times 2, you get 4, but that's still under the radical. What is the square root of 2 for? 2. So we take 2 times 2, so my hypotenuse is 4. Right. Okay, number 2, let's draw another 45, 45, 90 triangle. Now let's say you get to your homework and the picture looks like this. So they only give you one of the angles. Can I still apply these theorems? But I don't know, it's a 45, 45, 90 triangle. They don't tell me. It's got to equal 45, right? Because that's 90, because it's got a little square on it. And that's 45, which means the other one has to be 45. So just know, even if they don't tell you they're all 45, we have enough information to know for sure that it is 45. Okay, this time we're going to say that the legs are x and y, and the hypotenuse is going to be 12 square roots of 2. Now these are, if anything, the trickier of the two scenarios here. So if we have the legs, I know that the hypotenuse is whatever the leg is times the square root of 2. I don't have the legs. They don't tell me either one of them. But I do know the hypotenuse. And keep in mind, how I found the hypotenuse, where this came from.
Teachers and students, obviously we should disregard that latest bell and the bell to start fourth hour, to end the third hour will ring at 11:15 as normal. Thank you.
Okay, so keep in mind where this 12 square roots of 2 came from. To find the hypotenuse, you take this side length times the square root of 2. So when I did that, I don't know what S is, I don't know what S square roots of 2 is, but when I did that, I got 12 square roots of 2. So by doing this, I can find what S is, what those legs are. Now, if you see something like this, try not to work too hard. If S square roots of 2 equals 12 square roots of 2, what does S have to be? Yeah, right? If they're both square roots of 2 and, right? It has to be a 12. Now, if you're like, what? Okay, just divide by the square root of 2, divide by the square root of 2, square root of 2, square root of 2, those are going to cancel out, so S equals 12. Okay? Now, S, remember, in a 45, 45, 90 triangle are my legs. So what do X and Y equal? 12, yeah. So X equals Y, which equals 12. Okay, let's move on to the 30, 60, 90 triangles. All right, so number 3. All right, so we've got our 30-degree angle, our 60-degree angle. All right, so X is going to be right there, Y is going to be the other leg, and the hypotenuse is going to be 6. All right, so remember, ideally what we want is we want that shortest side. So how you pick out the shortest side, find the 30-degree angle, it's going to be the side across from that. Ideally, I would have that side because then I can just kind of plug in the numbers from there. In this case, I don't have that. Remember, this side right here, that's your S in your formulas. That's what you're writing everything in terms of, okay? Now, what would be nice, if I don't have that shorter side in a 30, 60, 90 triangle, the hypotenuse is really easy to find because remember, if you have the shorter side, the hypotenuse is always double that. But I have the hypotenuse, don't I? It's 6. So if the shorter side, double that as the hypotenuse, what is that shorter side? 3, yeah. It has to be 3. So in this one, I know X is 3. And then to find Y, it's similar, but you have to keep these separate, okay? The other leg in a 30, 60, 90 triangle is the shorter side, 3, times the square root of 3. So you have to keep those separate because the other one's the square root of 2. That's what you got to do for that one, okay? Okay, number 4, let's draw another 30, 60, 90 triangle. Not to scale, obviously. Now let's say kind of like the 45, 45, 90 triangle is, if this is all the information they gave me, I see a 30-degree angle, do I have enough to conclude that this is a 30, 60, 90 triangle? Yeah, because if this is 30 plus 90, yeah, the other one would have to be 60, okay? So in this case, we are going to have this side be 6 square roots of 3, this side be X, and this side be Y. Now once again, remember in a 30, 60, 90 triangle, that shortest leg, the shortest side, is going to be what we're looking for. That's going to be your S. That's kind of like your starting place. So the side opposite the 30-degree angle, that's what I need right there, and I don't have it. What I do have is I have the other leg. Now remember, in a 30, 60, 90 triangle, where that comes from, in a 30, 60, 90 triangle, it's S square roots of 3. That's what that leg equals. Well, I know when I take S square roots of 3 in this triangle, I get 6 square roots of 3. So what is S? 6, right? S square roots of 3 equals 6 square roots of 3. S has to be 6. So we're going to make those equal. Which means what variable is 6? X. X is 6. Which, in a 30, 60, 90 triangle, how does that help you find the hypotenuse? It's double it. It's always twice as long. So y would be 12. Okay, questions so far? That's all you're doing in your homework today. But as promised, I'm going to throw a couple of extra examples up here for more of what you're going to have to be doing on Monday. So, number 5, let's draw a little bit bigger triangle. And what we're going to do is we're going to kind of show the altitude or the height of a triangle, which means that's a 90-degree angle. It goes from the top of the triangle straight down to the other side. In this left-hand triangle, that bottom angle is going to be 45. In this triangle over here on the right, that's going to be 30. This side right here is 7 square roots of 2. Okay, this little bottom angle here is C. The altitude is A. This other hypotenuse is B. And then that bottom is D. So notice in this one, I have a 45, 45, 90 triangle on the left, and then I have my 30, 60, 90 triangle on the right. So let's look first at my 45, 45, 90 triangle. Remember, the 45, 45, 90 triangle is an isosceles triangle. So if that's the hypotenuse, these are my legs, which means A and C are the same thing. Now to find A and C, in A, you have to keep these separate. It's probably the hardest. Well, maybe the hardest part about today is just keeping these two formulas separate. In a 45, 45, 90 triangle, the hypotenuse is S square root of 2. The length of a leg times the square root of 2. So what's the length of the legs here? Yeah. 7 square root of 2 equals S square root of 2, which means S has to equal 7, which is going to be those legs right there. So A and C are both going to equal 7. Now, look over to the other triangle. What I need to decide is I need to decide what side that 7 is in my 30, 60, 90 triangle. Is it my shorter leg or longer leg? See the 30-degree angle? It's my shorter leg, which is really nice because that's my S, right? That's my S. Which means to find B, to find my hypotenuse, I'm going to multiply by 2. So my hypotenuse is 14. And to find D, to find the other leg, I'm going to multiply the shorter leg, which was 7, and I'm going to multiply it by the square root of 3. So 7 square root of 3. Okay, last one. Let's draw another big triangle here. See if I can do a better job drawing it to scale. And the other class, we're doing the same thing. Drop a line straight down to the bottom. And this time, this left-hand angle is going to be 60. The right-hand angle is going to be 45. This left-hand side is going to be 4. Square roots of 3, the altitude will be A, these bottoms will be C and D, and then the other hypotenuse is going to be B. Okay, so notice, I kind of have to start with my 30, 60, 90 triangle here. And in the 30, 60, 90 triangle, I have the hypotenuse, okay? And the hypotenuse is 4 square roots of 3. Remember, in a 30, 60, 90 triangle, the hypotenuse is twice the smaller side, right? Twice the smaller side. So, the smaller side is half of whatever the hypotenuse is. So if the hypotenuse is 4 square roots of 3, what's the smaller side? 2 square roots of 3, right? 4 square roots of 3, half of that would be 2 square roots of 3. Now, be careful here. Which one of these is my smaller side? Is it A or C? C, right? Because that's my 60-degree angle, which means this is my 30-degree angle. So it means C is going to be 2 square roots of 3. Now to find A in a 30, 60, 90 triangle, that other leg is going to be S square roots of 3. Okay? So you're going to take S, you are going to take the length of that shorter leg, which is 2 square roots of 3, and you're going to multiply it by the square root of 3. Okay? Kind of like we did before, you can multiply the 3's together. 3 times 3 is 9, but it would be the square root of 9. The square root of 9 is 3, and 2 times 3 would give you 6. So A is 6. Which then we can move to the 45, 45, 90 triangle. So if A is 6, what's D? Also 6. And B, once you know the S, once you know the length of that other side, the hypotenuse in a 45, 45, 90 triangle is going to be 6 square roots of 2. Yeah, 6 square roots of 2.